again to my overview of association rules. The material that I'm going to be using in this video and the next one, some of it belongs to Professor Saeed Saeed. You can find it at www.saeedsaeed.com, and some of it is adapted from the paper called An Overview of Association Rule Mining Algorithms by these two professors. Association rules. To define an association rule, generally it's a pattern that states when an event occurs, another event occurs with certain probability. So if event X happens or occurs, what are the chances of another event Y happening? So association rules essentially are just if-then statements that help discover relationships between unrelated data in a data repository, or at least relationships between data that seem to be unrelated in a database or a data repository. When we say if-then statements, what that means is the same as the first definition, i.e., if event X happens, then event Y also happens, or the other way around. What that means is we are trying to find the relationships between objects which are frequently used together. For example, if a customer walks into a market and he buys one item, then what are the chances of the customer buying another item in the same transaction? So association rules, they find all sets of items, we call them item sets, that have support greater than the minimum support. So we need to compute a value here called support. Then using the large item sets to generate the desired rules that have confidence greater than the minimum confidence. So here we need a criteria. We need to compute two values, one called support and one called confidence, and use them to find item sets. A typical and widely used example of association rules is market-based analysis. The way supermarkets are designed, the way the layout is designed, the way catalogs even are designed is usually based on association rules. Now, for example, if the customer buys milk, then he may also buy cereal or cornflakes. Or maybe if a customer buys a tablet computer, then he may also buy a case or a cover for that tablet computer. So these are sort of if-then statements. These are association rules. So in general, there are two basic criteria that association rules use: support and confidence. We mentioned that before, to identify the relationships and rules generated by analyzing data for frequently used if-then patterns. Association rules are usually needed to satisfy a user-specified minimum support. So we compute support and we need to have a minimum value of that support, which is preset by a user-specified, and at the same time a user-specified minimum confidence at the same time. So we need to compute these two values, support and confidence. We'll come to how we can compute them, and we need to have two preset values for them: minimum value for the support and minimum value for the confidence. So if, let's say, we have a rule X implies Y, what that means is if the customer buys item X, then he will also buy item Y. We compute the support by finding the frequency of how many times in our database of transactions, how many times the X and Y items were bought together over n. N is the number of all transactions, and the confidence is the frequency of X and Y happening together over the frequency of X, how many times X was bought. And then we can also compute the lift, which is support over the support of X times the support of Y. We need to be familiar with some basic concepts. For example, if we have a supermarket or a store, then we can create a set of all items in the store, everything that the store sells. These are components or contents of our item set. So the item set equals item 1, item 2, all the way to item M. We have M items in the store, the overall number of items in the store. And then we also need to have a transaction database, all the transactions, a set of all transactions. Capital T equals, it's a set of T1, T2, all the way to Tn. So we have n transactions, and each of these transactions has one or more items of the set I. So each of these transactions is a set such that the contents of T actually are a subset of I of all the items. And each transaction of these is usually given a transaction ID, a T ID, as you see here. Now, let's take a simple example for things to make sense. Let's assume that we have this transaction database. In the first transaction, the customer bought items A, B, and C. Second, A, C, and D. Third, B, C, and D. Fourth, A, D, and E. Fifth, B, C, and E. So this is our transaction database. Transaction 1, 2, 3, 4, and 5. And the item set, the item database, all the items in the store are item A, item B, item C, item D, and item E, as we said here. So that's I, and then T is all these transactions. And now we say, for example, what are the chances of the rule that says if the customer buys item A, then he will also buy item D. Will we compute the support? We said support is the frequency of X and Y together, so frequency of A and D together, nothing there, that's 1, A and D, nothing there, that's 2, over N, the total number of transactions, that's 2 over 5, that's support. And then the confidence, we said, is the frequency of X and Y together over the frequency of X. So the frequency of A and D, we said it's 2, that's 1, that's 2, and then the frequency of A, 1, 2, 3, so A appears 1, 2, 3 in the transactions, and we continue in the same way. We can also compute the lift as we mentioned here. Just to take maybe another example, a rule of a customer buying C and A at the same transaction. So we compute the support, the frequency of A and C, or C and A together, that's 1, A and C, that's 2, so that's 2, and then over N, which is the total number of transactions, over 5, the confidence is 2 over 4. We mentioned the frequency of C and A together is 2, and the frequency of C now is 1, 2, 3, and 4, as you can see there. Remember, though, we need to have preset values for the minimum value of support and the minimum value of confidence. I'm going to stop here. In the next video, I'll be explaining 2 of the most commonly used algorithms for mining association rules from data. Thank you very much for watching, and I'll see you in my next video.